In this video, I will be demonstrating how you can create a linked list by adding nodes at the rear end. In the last video, you have seen how we can create a linked list by adding nodes at the front end. We used to keep adding nodes at the front and create the linked list. Now, our create function will add nodes by appending nodes at the rear end. Like say, this is the structure we will going to use for the node. And how you will going to create a list. So initially you will have a head which is null. There will be, this is a empty list. It specifies that it is a empty list. So now I'll create. So I'll going to create 5 nodes. Say n is 5. You will create the first node. Say this is the first node in the list, and you will update the data, say 7. And since this is the very first node and this you are appending at the end, so the link will be null. You are appending at the end, no? That's why you update the data and link null. And say this is a new node, nn, it represents nn, and say it happens to be 1000. This 1000, since it is the start of the node, we have created, this is the first node, we need to update the head here as 1000. Okay, now what you need to do, again you go for the second node because n is 5. This time you will be adding node at the rear end. Say this is the rear end. We create a list by adding nodes at the rear end. This is how we keep adding nodes and establishing the links like this. This is the last node we have, fifth node, and that will going to have the link as null. Meanwhile, we need to, whenever we create a new node, say 2000, its address we must update in the previous node. So like this. Again, a new node you have created, this address must be reflected here, 3000. So this is how whenever you create a new node, you must reflect back the reflect that new address in the previous node. So how you can do it? Normally, when you now say if I ask you add a node at the rear end, so you need to traverse here. So now I'll not going to do that because continuously I am adding. What I do when I add a node, I remember the address and go, when I go back or when I come for the new node, I use this remembered address. Say now you are adding this node, second node you are adding this node, this first node's address is with you, so you remember it. Then what you did now, say you have remembered it in a variable temp. So your previous node is temp. When you add a new node, when you append a new node, what happens here? This is a new node and its link will go in the temp's link. So temp link will be nn. So this is how you will be using. Now when you go again, when you go for the next iteration, because you are using a loop, when you go for the next iteration for a new node, what you do? Remember this nn as temp. Remember this nn as a temp. Then when again you create a new node, and in that new node a link will be null because that is the last node, but temp previous node's link will be nn. So this is how you are supposed to write the code. You have to add the node. This way what happens, you will be making the time complexity lesser, so the time consumed will be less. If you every time if you traverse the list and add, that will be time consuming. So what is the trick used here? Before you go for the next iteration, the new node which you have created latest, remember that as a previous node or temp. So when you create a new node, this new node should be stored as a link of temporary node. So I'll demonstrate that thing. I'll write the code for it. Then again we'll have a dry run for it. So in the last video, I had taken like we had defined a class for that linked list, class linked list or list you can say, and since it is a non-circular list, we used to represent with the head. And already what is the type of structure? The structure I have shown you here. What is the structure? It is a node, struct node, and data and link will be there. So this node structure is there with us. Now it is a private, so go for some public methods wherein you will be defining create function and display function. Just to initialize the head, I'll be using a default constructor. Say head is initially null because the list is empty. Then you have a function void create that will going to create a list by adding nodes at the end, and then you have a display will remain as we did in adding creating a list by front node, adding node at the front end. Now let us define create function. So what create is basically doing, it is creating a list by adding nodes at the rear end. So let's define it now. Since it is not returning anything, it is of void, and since it is a method of class list, we have to bind, we are making it non-inline by defining it outside. So then we'll have some pointers, one pointer nn for new node, and I'll be using temp for storing address of previous node. So this is there. Then we'll have number of nodes int n and I for iteration. Then ask how many nodes we have, how many nodes you want to create in the list. So enter number of nodes. Okay, the user will give that as a n. Now you need to run a loop for n iterations. So for I0, I less than n, I plus plus. We need to now keep creating the list by appending a node at the end. So for every iteration we need to create a new node, nn is equal to new node. So this will create a new node dynamically at runtime. Then enter the data. Say cout, enter data in it, enter data. But you need to check like is nn is null. That is a good programming practice. But now due to shortage of time, I am not adding that. You can add it. So enter data, then scene, your nn data will be there. So if nn is allocated, memory is allocated successfully, nn will be not null. So you have to check if nn equals to null, you have to say memory failed, memory allocation failed, and you have to exit. So now enter data, we did nn. Since we are appending a node at the end, it is for sure that the link of the new node will be null. This is how these two things about the node I have updated. Now I need to check, is it the first node? How I can check? There are two ways. I can check inspect the value of head. Head is available to me because it is a member function. Head is implicitly available. You can use head. If head equals null, it is the very first node. Or even you can use if I equals to 0. Because for the very first iteration I will be 0. So you are in the very first time you are creating a node, it means this is the very first node. If this is the very first node, what happens? You need to update the head. Head will be nn now. Say here you need to update the head like this. Here I have updated. Initially it will be null. When you create the very first node, the address of the very first node should be updated. That's why we have to make this nn as a head. And one more thing you need to do, you have to remember this nn, as a temp. Say you have remembered it. Now there is no point in going down, so you should go back to the loop now. How we go back now? There is a statement in C++, continue. So what it does now, it jumps back to the loop. So this is how it is done. If I equals to 0, this much job I did. In case if I is not equal to 0, then that is second node onwards. Second node onwards, there is no need of updating head because already it is done. So what you need to do now here, you need to temp, last time you have remembered that temps link will be made nn. This is a new nn, what new node you have created just now, that will be there. And then again remember this nn as a temp. Remember this nn as a temp. That's all you have to do in the loop. This is the end of loop and this is the end of function. This is how the create function will be there. Let's have a dry run for it. How you can see now here. So initially I'll demonstrate here. I'll have a dry run here. Look at this top. Initially head will be null. Okay. Let's create number of nodes as 4. We'll take n as 4. So n is 4 here, number of nodes. You will be creating a new node. Okay, a new node is created over here. Let's say its address is 1000 and you have updated some data, say 7, and link you have made it null because you have created this nn null. Okay, I equals to 0 true because it's the first iteration. So nn will be stored in head. Nn is what here now? 1000. This is our nn. So nn is 1000. So you updated the head now. You changed the head to 1000. Fine. And you are remembering there is one more pointer like here. There is a temp. You remember that as a nn 1000. Okay. Then continue. Continue will go back. These two statements will be skipped, bypassed because of this continue statement. Then I will be now, what will be the value of I? I will be 1. So 1 less than 4, it is true. So again we go back, again we create a new node. Okay, this is your nn now. Now this is nn. Let's say it is 2000. Then here I is 1 now. 1 equals to 0 false. So you will not enter into the if block. You will come down. So nn will be temp link. Temp, what is temp? 1000. 1000's link you made, you changed to nn. Nn is now, new nn is 2000. So this is how you established a link here now. Okay, then what is the new nn? New nn is 2000. That you again remember in temp. Okay, again you go back. Now I will be 2 less than 4 true. Again a new node is created. You will be updating the data in it. Say some value here. It was null here. Again here some value, say 3, and again null. Now again I is 2. 2 equals to 0 false. You will come here, temp link. Temp is 2000. 2000's link, this will be updated with the nn. Say nn is 3000, and this is how you establish a link here. 3000 it will be. Then again you remember that nn as a new node, that as a temp. Go back, I will be 3 now. 3 less than 4, again true. So again a new node you will create here. Again you will update it, set data with some value. Then again I is 3. 3 equals to 0 false. You come down. Temp you have remembered 3000. 3000's link will be made. New node. Say new node is 4000. So 4000 is updated here. Then what happens? You remember that 4000. And again you come back. Now I is 4. 4 less than 4, it is false. So you stop. Now you can see by the time you finish with the loop, you have a list in your hand and the head is initialized. So now if you call a display function, what happens? It displays the list. So if you find any problem, any doubt in this, you can ask me in the comment section. So this was the dry run. Now you know how we define display. Once again I will define it for you. Because we have a head of the node in our hand. So what we do, we take one temporary pointer, node star temp. In that, when we assign, we store head. Then simply we will run a loop while temp not equal to null. Till you don't exhaust the list, you will keep displaying it. See out. So temp arrow data. And this is what the creating a linked list by adding a node at the rear end. If you don't use this trick, what happens? The time complexity will increase. Say every time you traverse. So you have created a one node, you traversed. Again you created 2 nodes. For the third node you traverse 2 nodes. For the fourth node again you start from traversing and come to the end. For the fifth node, again you will traverse all right from beginning. This way what happens, the time complexity will be big O of n square, it will be approximately, because you are creating a list. It is of creating, not adding, just creating a list. But with my algorithm here, I'll be using only a single loop. See, this is a single loop I am using for n nodes. So what is the time complexity of my algorithm? It is big O of n. The create will have a time complexity of big O of n. So in a nutshell, what I can say, we discussed creating a list by adding nodes at the end, thereby using a loop in it, remembering the address of previous node, and whenever we come for the new node, again we used that previous link we updated with the new node. This is what we have. In the next session we'll see more operations about linked list. Hope you enjoyed the session. Thanks for watching.